This is homework 21, intro to sequences. So define a sequence. It is a list of numbers. List of numbers. There we go, there's a sequence. Fine. Find the first 6 terms of the sequence. Well, let's plug stuff in. This would be 2 times 1 minus 1. 2 times 1 is 2. 2 minus 1 is 1. This would be 2 times 2 minus 1. 2 times 2 is 4. 4 minus 1 is 3. This would be 2 times 3 minus 1. 6 minus 1 is 5. We can see also that our number in front of our variable is a 2, and that we're going up by 2 each time, so this would be 7, 9, and 11. And I'm fine with that as long as you say, hey, we're going up by 2 each time, because that's linear. It'll only work if this power is to a 1, so it's not going to work here. We're not going up by 2 because that's not to the first power here. So we've got to actually plug and chug here. So our first one would be 2 times 1 squared. 1 squared is 1. 2 times 1 makes 2. 2 times 2 squared. 2 times 4 makes 8. 2 times 3 squared. 2 times 9 makes 18. 2 times 4 squared. 2 times 16 makes 32. 2 times 5 squared. 2 times 25 makes 50. What are we going up by here? We're going up by 6 here, right? 2 to get to 8, we're going up by 6. 8 to get to 18, we're going up by 10. 18 to get to 32, we're going up by 14. So that was 6, 10, 14. 32 to get to 50, we're going up by 18. So the next one should be 70, should go up by 22, so it should be 72. Let's see if that works. 2 times 6 squared equals 2 times 36, which is 72. Look at that. Found a little pattern. Our next one, n over n plus 2, so this is going to be 1 over 1 plus 2, or 1 over 3. Next one would be 2 over 2 plus 2, or 1/4, right? Because that's 2/4, not 1/2. Jeez. Next one would be 3 over 3 plus 2, or 3/5. And I should have left this as 2/4. Let's leave that as 2/4. Do we see a pattern? 1, 2, 3. Next one's going to be 4. 4 what? 4/6 or 2/3. Next one's going to be 5/7. Next one's going to be 6/8 or 3/4. We'll do this last one. 6 would be 6 over 6 plus 2. And that's where we get 6/8 from, or 3/4. So finding patterns is good. So this one would be -1 to the first power, that's -1. -1 squared is 1. -1 cubed would be -1 times -1 times -1, that's -1. -1 to the fourth, that would be 1, and we can see the pattern here, -1 and 1. N squared, so 1 squared over 1 plus 1, so that's 1 over 2. Next one will be 2 squared over 2 plus 1, so that's 4 over 3. Next one would be 3 squared over 3 plus 1. So that's 9 over 4, 9/4. Let's do one more. Next one would be 4 squared over 4 plus 1. So that's 16/5. Do we see a pattern? Well, definitely here. 2, 3, 4, 5. So that'll be 6 and that'll be 7. And what's happening here? 1, 4, 9, 16. We're just squaring those numbers, right? So this will be 25 and this would be 36. Our next one, this plugging in a 1 will be 1 plus 1 cubed, 2 cubed, which makes 2 times 2 times 2, which is 8. This is 2 plus 1 cubed, which is 3 cubed, which is 3 times 3 times 3, which is 27. Next one would be 4 cubed, right? We're seeing the pattern here, right? 3 plus 1 cubed, 4 cubed, 2, 3, 4, right? 4 cubed, 4 times 4 times 4, so 16 times 4, what's that? 64. The next one is 5 cubed, so that's 125. 6 cubed would be 36 times 6, so that's 36. 318, 216, and then I think we're going to get like 512. Let's see here. So 7 cubed is 49 times 7. Well, 50 times 7 would be 350. So 300 and what? 43? 343. Right? Let's do it. 9 times 7 is 63. 7 times 4 is 28. Plus 6 is 34. Yeah, 343. Look at that. Alright. 3. Find the next 4 terms of this sequence. So what are we doing here? 1 to 4, we're going up by 3. 4 to 9, we're going up by 5. 9 to 16, we're going up by 7. So the next one should go up by 9, right? So what's 16 and 9 would make 25. Next one should go up by 11. So that should be 36. Next one should go up by 13. So that would be 49. And the next 4, so we need one more. So the next one would be 15, so that's what? 64. 31, 24, 17. So it looks like we're going down by 7, right? Down by 7. Down by 7 would be 10. Down by 7 would be 3. Down by 7 would be negative 4. Down by 7 would be negative 11, right? Next one, 1, 2, 4, 8. Let's see here. Going up by 1, going up by 2, going up by 4. Let's see here. Let's see if we can do something here. This is first term, second term, third term, fourth term, right? So how about this is n to the n minus 1 power? Is that what we're doing? So the first one would be 1 to the 1 minus 1 power, so that's 1 to the 0 power, which equals 1, so that's right. The second one would be 2 to the 2 minus 1 power, which would be 2 to the first, which equals 2, so that's right. The third one would be 3 to the 3 minus 1 power, which is 3 squared. Oh no, that gives us the first 2, but then that one should be a 9 here. So what are we doing here? How can I do this? 1, 2, 4, 8. How about 2? 2 to the n minus 1 power. So that would be, the first one would be 2 to the 1 minus 1, which would be 2 to the 0, which is 1. Next would be 2 to the 2 minus 1, which would be 2 to the first, which is 2. Next one would be 2 to the 3 minus 1, which is 2 squared, which is 4. Hey, we did it. Alright, so 2 to the n minus 1. So, now that we found that, right, that's kind of tricky. That's a tough one. So then our fifth one would be 2 to the 5 minus 1, or 2 to the 4th. Right, so this was 2 to the 4th, so what is that, 16? And then, so pretty much each time, what are we doing? We're multiplying by 2, right? I could have seen that right off the bat, too. Times 2, times 2, times 2. So this would be 32, 64, 128. Whew. Yeah, sorry that took so long. That should have been an easier one. Should have recognized that a little quicker. This one here looks like we're adding 3. Adding 3. Negative 2 plus 3 makes 1. 1 plus 3 makes 4. 4 plus 3 makes 7. 7 plus 3 makes 10. 1/3, 1, 5/3. Let's change that instead of 1. Let's call that 3/3. Do we see a pattern? Well, 3, 3, 3. Our denominators stay in 3. Alright, what's happening with our numerator? 1, 3, 5. So what are we doing? We're adding 2 to it, so that would be 7, 9/3, or 3. Plus 2 would be 11/3, plus 2 would be 13/3, right? Next one, 1.3, 3.8, 6.3. Let's see here. Hopefully we're adding here. 1.3 to get to 3.8 is adding 2.5, right? 3.8 plus 2.5 makes 6.3. 6.3 and 2.5 make 8.8. 8.8 and 2.5 make, what is that, 11.3, and 2.5 make 13.8, and 2.5 make, what is that, 16.3. G 1, 8, 27, 64. This will be 2. No, let's try. How do I go 8? 8, 27, 64. This is 27 is 3 cubed. 8 is 2 cubed. 1 cubed. 64 is 4 cubed. Look at that. So it's just n cubed. N cubed is our pattern here. So the fifth term would be 5 cubed, which would be 125. 6 cubed, which is 216, and 7 cubed, which is 343, right? Alright, next one, 9, 16, 23. Let's see here. We're going up by 7, going up by 7, we're going up by 7. 30, 37, 44, 50, what? 51. -6, -2, 2. Alright, we're going up by 4, right? 2 plus 4 makes 6, plus 4 makes 10, plus 4 makes 14, plus 4 makes 18. That was an easy one. Graphing the sequence. So, first the domain. The domain is, this is inputs down here and our outputs up here. So that's 1, 2, 3, 4, 5, 6, right? Or this was our n, and this was our a of n. Or this was our x, and that's our y. Right, so our domain, or our domain and our range. So our domain is 1, 2, 3, 4, 5, 6. Our range was 1, 3, 6, 10, 15, and 21. So we're just plotting these points. So our first point is 1, 1, 1, 1, 2, 3, 3, 6, 4, 5, 6, 4, 10, 7, 8, 9, 10, 5, 15, 11, 12, 13, 14, 15, and 6, 21. 16, 17, 18, 19, 20, 21, right there. So there's that graph. Same thing here, domain. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. Our range are these numbers, 1, 5, 9, 13, 17, and 21. And we're just going to plot these again. 1, 1, 2, 5, 2, 3, 4, 5, 3, 9, 6, 7, 8, 9, 4, 13, 10, 11, 12, 13, 5, 17, 14, 15, 16, 17, and looks like we're going up by 4 each time, right? We don't need to do the rest of these. You guys can do those on your own. I don't need to do that. Application. To begin the halftime performance, a high school band marches in the football field in the pyramid formation. The drum major leads the band alone in the first row. There are 2 band members in the second row, 3 in the third row, 4 in the fourth row, and so on. The pyramid formation has 10 rows. How many members does the band have? So this was 1, and then there's going to be 1 or 2, right? Totals 1, 2, then we had 3, right? And then we had 4. So we're just adding all this up. So 1, 2, 3, 4, 5, right? 6, 7, 8, 9, 10. We're just going to add up all that. So 4 and 5 make 5, 5. So that's, what is that? 5, 10, 15 here. And 6 and 9 make 15. 7 and 8 make 15. So that's 30, 40. So that's 55. 55 people. Your best friend tells you a rumor. Every hour a person who was told the rumor tells someone new. After 6-hour period, how many people will have heard the rumor? So let's see here. Your best friend tells you a rumor. So at first, within the first hour, 2 people know, right? After a 6-hour period, how many? Okay, every hour a person who was told the rumor tells someone new. Okay, wait a minute. So now there's one person that knows it, because that's the person who told it. So I know it now. Now I'm going to tell someone new. And so now there are... So now there are this is kind of difficult, because it's just how do you start it? It depends on when time 0 is. That's always difficult. Are we talking about it after the person tells me or before the person tells me? So there's one way it could be the first person knows, and then there's two people that know, us, me, and the first person. But then I'm only telling one person because it says every hour a person who was told the rumor tells someone new. So we're going to say that that's including the first person. So now there's two people, and that doubles. So we're just doubling each time. 2, 4, 8, 16, 32, 64, 128. And so then the question is, after 6 hours, is when is that first one? So this, I think it's going to be 1, 2, 3, 4, 5, 6. Or you could say this was 1. But that's it. No matter, you know how to do the problem.